Hello all, let's start with our today's DSA with this amazing playlist by dsa.chaicode.com. Use this link to get a 7-day free trial. Now let's start. And our today's question is swap nodes in pairs. Given a head of the linked list, given a head of the single linked list, swap every two adjacent node and return the new head. You must swap the actual node rather than just their value. Okay, so this is our question. 1, 2, 3, 4. Now, so this is our list, and the answer would be 2, 1, 4, 3, and null. Why? Take this 2 and swap this 2. Now take this 2 and swap this. Okay, see, we just take this 2 and swap it. We just take this 2 and swap it. But what if 1, 2, 3, 4, 5, 2 is be the answer for this 2, 1. Now 3 and 4, it will be 4, 3, and the 5 will remain same. Why the 5 will remain same? Because there is no 2 adjacent. Okay, these 2 are adjacent, these 2 are adjacent, and these 2. That's it. Okay, so this is a single one. We don't consider this is at node. This null is not node. Okay, so the single goes to here. We just take these pairs. Now, what could be a solution? It will be a solution, but it is not mentioned in the question to do, but we will do it. So this is our list. What if? What if? Simple. What if we take two pointers or maybe one? We just take these two and swap their values. Just swap their values. It will become 2, 1. Then again 3, 4. Now come to these two. Now swap their values, not the nodes, just swap their values. It will become 2, 1, 4, 3, and then simply null. Okay. Although the actual node rather than their value, although if we do it, it will give us a right answer, which is nothing but simple. Given our head, take a node or current to just point towards everything, while the current and the current next present, swap the value of current value and current next value. Simple. And move the current 2 step. And at the end simply return head. Let's evaluate it. Why we do current next? Because in this step our current is here. Okay, now we have to skip this element also and we have to reach this portion. So for this we just took a 2-step jump. Okay, yes, we done it. Let's run code it. Okay, so what is our solution? And this is our solution. Okay, so simple. Take a current, head, then simply while current is not equal to null and current next is not equal to null, then simply we have to now swap. We have to perform this swap, but how can we actually swap this? Let's take it. So first take two values. Our values are integer. We are given the linked list, which is where our values are actually in integer. So take two value. Value 1 is nothing but current value. Int value 2 is nothing but current next value. Then simply current value is what? So for current, okay, so our linked list is 1, 2, 3, 4, and then null. Our current is actually here, and this is our current next in. So this is value 1 and this is value 2. So the current should point it to this value, this 2. Okay, so current value should become value 2. Next value should become this value 1. So the current is equal to, or my current is equal to, current next value is equal to value 1. Then simply do a two step, because after this 1 and 2 we need to move our C to this 3, because we just the 1 and 2, the pair of 1 and 2. Okay, so for that simply perform current equal to current 2 step, current next 1 step, then another one next is 1 step, and simply return head. Run it. Yes, it's working. But if we submit it, execution is done, perfect for every test cases, but we are doing a restriction failure. Okay, why? Actually this is lead code introduced it very recently. So you are not allowed to modify the values. You must swap the nodes by relinking their pointers. This is actually given to our question, like you must solve the problem without modifying the value of the list node. Okay, but you can do it like this. It is big O of n, time complexity, simple. Our time complexity will become big O of n, and there will be no space complexity, so it will become big O of 1. Simple. This is our time and space complexity. Now come to the optimized approach, or rather a correct approach. And no, let's do it here. So simple, 1, 2, 3, 4, and null. Okay, fast. And what is our head? Head is simply 1. Okay, so first we are taking a dummy pointer, or yeah, take a dummy pointer, as simple. Take a dummy pointer at null or any value. Let's take it as dummy, and also we just take another pointer like tail every time to this dummy to just traverse the whole list. So what we do is we take a dummy pointer and then pointing it to head. We take a dummy pointer and pointing it to the head. We take a dummy pointer and pointing it to the head. Okay, and we take a tail, or okay, we just take a dummy pointer pointing to head, and we also need like a tail, and for that we are using a previous pointer. Let's take it as P. Okay, it will be easier. So now how many element we have to swap? We have to take a pair. Okay, and what is the pair? This should be the next, like the next pair of each other. So uh, let's take it. So this is a pair. We are taking two pointers at A and B. And what is A? A is the next element of the previous, not the dummy. The previous. The previous is also pointing to dummy. So the dummy so the previous next. Okay. And the B is previous next next. Okay. Now we have to relink it. And how what should be our relinking process? So simple. We have to take this one and pointing it to 3. And after pointing it to 3, we just remove this. And now we have this B. B should pointing to this A, because we are doing some opposite. And after this, and now the previous should point to the previous next, and rather this one. This should point like this, and okay, the B is there. So this one simple. And the previous now pointing to the very next element, which is A. Just remove me the head, and now this P pointing to this. So now what is the previous here? Here is the previous is the dummy. So the previous next is going to 2. It simply means the dummy next is going to 2. So we just remove this link and we just put previous here. Now after all of this operation, our linked list will look like this, like this one. This is dummy pointing to B. This dummy pointing to B. This should be this. This dummy pointing to this B. It should be 2. Now the B pointing to A. It should be 1. And and one should point to 3. 1 should point to 3. And 3 should point to 4, and rest of the. And where is our previous? So just take our previous, and it's currently on 1. Take our A. Okay. Take our A and take our B. Now this is the linked list, and I should yes. Now it will be fine. So our previous, from this portion we got our previous at 1. Now A and B. A and B are simple. A is the previous next, B is the previous next. Simple. So now do the same operation. Same operation do again. This 3 points to the next one of this. We just remove this link. Now this 4 should point to this one, and now remove this link. And now the previous next. Okay, the previous next, this one, the previous next point to this B, and we just remove this node, and now the previous should point to the, and using this approach, now write the whole, like we are having a dummy, then we have 2, then simply we have 1, then 1 pointed to this 4, then this 4 pointed to this 3, then this 3 pointed to this null, and our P actually now in 3. And do we have any next element? No. Simple condition. And suppose and now if we return the dummy next, or this one, if we return this 2 as the new head, is the linked list correct from this 2 to this null pointer? Yes, it correct. So what we are taking? We are taking simple steps. First we just take a dummy node, point a previous, then we simply take A and B, then A should point to B next, then B should point to A, then B next point to A, then previous point to the B, next point to this B, then simply previous pointing to the A. So this is our simple approach. So, and I think we should do it again. So we have this dummy node, and also we have this 1, 2, and 3, and 4, and then null. Okay, we have our previous here. This is our A, this is our B. Okay, so what we have to do? First we have to point this A to this 3. So what this step does, this is step number 1. So this step number 1 does one thing, and take a text here. Simply A next is pointing to B next. Number 1 does this thing. A next is pointing to this B next. Now we have to point another thing in the next step. This B should point to A. And it is simple that the B next is simply pointing to A. The B next is simply pointing to A. Now this P, now this previous. Now we have to take our previous and point it to B. Okay, and it is simply, let's just move this to here. Actually this is number 2 and this is number 3, which is nothing but simply P next or the previous next, anything which would take, is simply going to B. And then next step we just take our previous and just put it to A in our fourth step. So in our fourth step we did simply previous equal to A, and previous is a pointer, or P is a pointer. So this is the fourth step we are doing in each operation. Okay, the question comes here, can be like at the end we have to return this dummy next at the end. And why we actually need a dummy pointer? To ensure this head, because take a guess, like 1, 2, 3, 4, 4, and then null. Our current head is this, but in our result our head should be this. Okay, our new head should be this. And if we take any normal operations to just reversing both part, then we just easily reach a condition where we have to specifically mention that our head should be this. But in this dummy node, sure that the dummy next is always our head. This dummy node approach always return, because maybe actually the head pointer which is given to us is still on this one, but we just return this return this head next or dummy next. We just return this dummy next so that we get our new head. For that reason we need a dummy node, and with this dummy node we can easily get our head. And to just for simplicity of our code we just use this dummy node. So let's just write down it. You can see here also it will also take it. So we are taking a first we are given a head simply, and we are taking dummy dummy node. Dummy is nothing but a node, and dummy next is pointing to head, and we take a previous node which is pointing to dummy. Okay, now take while loop while the previous is not equal to null, or let's take a and here, the previous next next is not equal to null. Why we need this? We need this just because when we reach this last element, see here, the p is actually in the last position. P is actually in the last, and after that there is nothing. Okay, so there is nothing to on that. So we don't need any operations after that. And also, if we consider 1, 2, 3, 4, and then 5, and we're just taking a odd even odd length, because even length we see. So this is our after operation, this is our node. We just have our previous in 3 because this is same. Now you may question why not 5, because 5 doesn't have any pair. Okay, so it is last node. So we are checking that if it is next is null for this condition, that their next is null, or the next is null for this condition. So for checking that at least we have two elements or not, because we have to swap in pairs, so we need pairs. And so take two pointers, one is something previous next, another pointer is nothing but next. Have to perform or write these four lines. Simply add this four line, a next equal to b next. Okay, this is our first line. Let's write down it, a next equal to b next. Simple. And a next is equal to b. So we done it. What is our next line? B next equal to a. Simple. B next is equal to a. Now what is our third line? Previous next equal to b. Okay, so previous next is equal to, and then simply our last line which is previous equal to a. Okay, it is simply previous equal to a, and at the end have to return the dummy next. Now just evaluate it. Yes, we did it. Now come, just take this. So this is actually our solution for this question. Okay, now write down the code here. Simple. We just first we need a dummy node and a previous node. So simply our take a dummy which is nothing but new list node, and it is a null node. Taking -1 would be better. So let's take a first point to this, that dummy, and dummy next is nothing but head. Just point it here. Then we take a previous pointing to the dummy. Then simply run our loop while the previous next is not equal to null, and previous next then again next is not equal to null. If this condition occurs, it's 4 step. Simple. This 4 step. These two are just to take 2 pointers. These two are just to take 2 pointers. Can you make it? Yes. It will be much more easier. So these two are just to point 2 pointers. Then this 4 step. This is common 4 step. You just copy paste it. No need to worry about it. So first we are having list node A, which is pointing to the previous next. Then we have list node B, which is pointing to the previous next. Simple. Then if we simply copy this and paste it here, this one, this should work. We need to add a semicolon at every step. It should work. This is the actual code I am writing here. Same code. And at the end, just return the dummy next. Okay, let's check it. First time copy pasting, it's working. Let's see, we checking restrictions, some post. Oh, we validated the restrictions, so we solve it. It also take one loop iteration, big O of n, and no space needed. So both of the condition have the same time and space complexity. But this approach, why we are preferring this approach? Because our question says not to swap values. So simply our time complexity would become big O of n. N is the length of the linked list, and we don't use any extra space. So our space complexity will become big O of 1. So this is our question. This is our code. Go use the platform. Use this link to get a 7-day free trial and solve the question. Use the platform. Go check out. Thank you. Thank you very much.